Hello and welcome. As you settle in, let me know where in the world and at what time you're watching. Now, get comfortable. Take a slow breath and let's begin. Tonight, we're going to take a journey together. Not through space and time in the way you might expect, but through the quiet, extraordinary transformation that happens to a human body when it leaves Earth behind for an entire year. This is a story of gentle change, of adaptation so profound yet so gradual that it unfolds like the slowest, most peaceful metamorphosis you could imagine. Close your eyes if you'd like, and picture yourself not as you are now, but as an astronaut preparing for the longest journey of your life. You've trained for years, your body conditioned, and your mind prepared, but nothing can truly ready you for what's about to happen. The rocket beneath you hums with a deep, resonant vibration that you feel more than hear, a gentle trembling that runs through your bones like the purr of some enormous, benevolent creature. As the countdown reaches its final moments, you're lying on your back, looking up through layers of reinforced glass at a sky that's about to become your new home. The weight of your body presses into the seat beneath you, every pound of flesh and bone held firmly by Earth's ancient, invisible embrace. This is the last time you'll feel this particular sensation, this heavy, downward pull that has shaped every moment of your existence since the day you were born. 3, 2, 1, and then the world changes. The first thing you notice isn't the roar of engines or the spectacular view of Earth shrinking below. It's something much more subtle, much more intimate. As the rocket climbs higher and higher, punching through layer after layer of atmosphere, you begin to feel lighter. Not suddenly, not dramatically, but gradually, like sinking into the world's most comfortable bath where the water somehow makes you weigh less and less with each passing moment. Your arms, which were pressed firmly against the armrests by the acceleration, begin to feel strange. They want to float. There's no other word for it. They simply want to rise, as if filled with some invisible gas, as if they're balloons tethered to your shoulders. You flex your fingers experimentally, and they respond with an odd, weightless quality, like moving underwater but without the resistance. The sensation spreads through your body slowly, peacefully. Your legs, which have carried you across countless miles of Earth's surface, supporting your full weight with every step, suddenly feel as though they're made of cloud. Your torso, your head, every part of you begins to experience this strange new lightness. It's not uncomfortable, quite the opposite. It's like discovering that you've been wearing an invisible, heavy coat your entire life, and someone has just helped you slip it off. This is microgravity, and your body is meeting it for the first time. The human body, you see, is an extraordinary piece of biological engineering. Every cell, every organ, every system has been shaped by millions of years of evolution under the constant, gentle pressure of Earth's gravity. Your bones grew thick and strong to support your weight. Your heart learned to pump blood upward against gravity's pull. Your inner ear developed delicate mechanisms to tell you which way is up and which way is down. Your muscles built themselves around the assumption that they would always need to work against this downward force. But now, in the space of just a few minutes, all of those assumptions have become obsolete. As you float there in your spacecraft, no longer pressed into your seat, but gently drifting within the confines of your restraints, your body begins what will become the most remarkable year-long conversation with an entirely new environment. It's a conversation conducted not in words, but in the language of cells and chemistry, of blood flow and bone density, of neural pathways rewiring themselves to make sense of a world where up and down have lost their meaning. The first whispers of this conversation are surprisingly gentle. You might notice that your face feels different, slightly puffy, as if you've just woken up from a particularly deep sleep. This isn't your imagination. Without gravity to pull the fluids in your body downward, they're beginning to redistribute themselves, flowing more freely toward your head and chest. It's like tilting a partially filled water bottle. The liquid finds new places to settle. Your crewmates, floating nearby, might look slightly different too. Their faces are a little rounder, their features softened by this gentle swelling. It's not unpleasant. They look well-rested, peaceful, like people who've been enjoying the most relaxing vacation of their lives. And in a way, that's exactly what your body is beginning to experience. A vacation from the work of constantly fighting gravity. But let's slow down and really examine this moment, this threshold between two worlds. You're suspended now in a space that exists between Earth and the vast cosmos beyond. Below you, through the spacecraft's windows, you can see the curve of the planet you've left behind, blue and white and impossibly beautiful. Above you, though above is already beginning to lose its meaning, stretches the infinite darkness of space, punctuated by stars that shine with a clarity you've never seen before. The silence here is different from any silence you've known on Earth. It's not the absence of sound so much as the presence of something else, a deep, profound quiet that seems to wrap around you like the softest blanket. There are sounds, of course, the gentle hum of life support systems, the quiet whisper of air circulation, the occasional soft beep of instruments. But these sounds exist within a vast envelope of cosmic stillness that makes even your own breathing seem loud and important. In this environment, your body begins its first tentative experiments with weightlessness. When you move your hand, it doesn't fall back to your side as it would on Earth. Instead, it continues moving in whatever direction you've pushed it until something stops it. The wall of the spacecraft, your own body, or perhaps nothing at all. It's like being underwater, but without the water, without the resistance, without the buoyancy that still, ultimately, has direction. Your inner ear, that remarkable organ that has spent your entire life informing you about your relationship with gravity, suddenly finds itself without its primary reference point. The tiny calcium carbonate crystals that usually settle in response to gravity's pull are now floating freely within the fluid of your inner ear canals. They're sending confused signals to your brain, like compass needles spinning wildly in the presence of a powerful magnet. This confusion manifests as a gentle disorientation, a dreamy uncertainty about which direction you're facing or moving. It's not the violent spinning sensation of motion sickness. That's too harsh a description for what's actually a rather peaceful bewilderment. Instead, it's more like the feeling you might have in those first moments after waking from a vivid dream, when you're not quite sure where you are or which way is up. Some astronauts describe this initial period as feeling like they're constantly falling, but falling in the most comfortable, endless way imaginable. There's no fear, no panic, because there's nothing to hit, nowhere to land. You're simply suspended in three-dimensional space, free to move in any direction with the gentlest push of a finger against a wall or the softest bend of knee. As hours pass in this new environment, you begin to notice other subtle changes. Your spine, which has spent decades compressed by gravity, slowly begins to elongate. The discs between your vertebrae, no longer squeezed by the weight of your upper body, start to expand slightly. You might grow an inch or two taller over the coming days and weeks. Not dramatically, not uncomfortably, but gradually, like a flower slowly unfurling its petals toward the sun. This stretching of your spine brings with it a particular kind of relief that's hard to describe to someone who has never experienced it. Imagine that you've been carrying a heavy backpack for so long that you've forgotten what it feels like to walk without it. The removal of that weight doesn't just affect your shoulders and back. It changes your entire relationship with movement, with posture, with the simple act of existing in space. Your muscles, too, are beginning to sense this new reality. The large muscle groups that have spent your lifetime working against gravity, your quadriceps, your glutes, your calf muscles, suddenly find themselves with very little to do. It's not that they stop working entirely, but their job description has changed dramatically. Instead of supporting your weight and moving you through a gravity-bound world, they now need only to provide gentle propulsion and control in an environment where the tiniest movement can send you floating across a room. This is perhaps one of the most dreamlike aspects of early space travel. The way the simplest movements become transformed into something magical. Push off from a wall with your fingertip, and you glide across the entire length of your spacecraft. Twist your body slightly, and you begin a slow, graceful rotation that continues until you decide to stop it. Reach for an object, and if you're not careful, you might push it away from you, sending it floating just out of reach while you drift in the opposite direction. Learning to move in microgravity is like learning to swim in air, but it's even more ethereal than that. When you swim, you still have the resistance of water to push against, the weight of your body to work with, the clear distinction between up and down. In space, you have none of these reference points. Every movement becomes a negotiation with physics in its purest form. Action and reaction, momentum and conservation, played out in slow motion in 3 dimensions. The first meal you eat in space carries its own quiet magic. Water doesn't pour. It forms perfect, trembling spheres that float in the air like liquid pearls. If you're not careful, these spheres might drift away from you, creating a slow-motion dance of tiny, floating worlds that catch and reflect the lights of your spacecraft. Food crumbs don't fall to the floor because there is no floor in the way you've always understood it. Instead, they float freely until the air circulation system gently carries them toward a filter or until you catch them yourself, plucking them from the air like fireflies on a summer evening. Even the act of drinking becomes transformed. Liquid has to be coaxed from its container, forming floating blobs that you chase with your mouth, or sipped through specially designed containers that prevent it from drifting away. It's playful, almost childlike, this new relationship with the most basic acts of survival. As your first day in space draws to a close, you begin to understand that you're not just visiting this environment. You're joining it, becoming part of it in the most fundamental way. Your body is already starting to shed the assumptions and adaptations of a lifetime spent under gravity's influence. Like a tree transplanted to new soil, you're beginning to grow in directions that would have been impossible in your original environment. The sleep that comes on this first night is unlike any you've experienced before. Without the familiar pressure of a mattress supporting your body against gravity's pull, you float within your sleeping bag, held in place only by gentle restraints that keep you from drifting into walls or equipment. Your arms don't rest at your sides. They float freely, creating the sensation that you're sleeping while swimming or perhaps sleeping while flying. Your breathing changes too, becoming slower and deeper in the perfect atmosphere of your spacecraft. There's no weight pressing on your chest, no gravity pulling at your diaphragm. Each breath comes easily, naturally, like the gentle rise and fall of ocean waves. The oxygen in your spacecraft is pure and clean, filtered and recycled with mechanical precision, carrying none of the earthly scents of plants and soil and weather that have accompanied every breath of your life until now. In this sleep, your dreams might be filled with floating, with the sensation of moving through space without effort or resistance. Your brain, trying to process these new sensations, might weave them into narratives of flight and freedom, of moving through environments that exist only in the realm of imagination. You might dream of swimming through air, of walking on walls, of reaching up to touch stars that hang just beyond your fingertips. And while you sleep, your body continues its quiet work of adaptation. Your heart, no longer working against gravity to pump blood to your brain, begins to beat a little more slowly, a little more efficiently. Your kidneys adjust their function to process the changed distribution of fluids throughout your body. Your bones begin the slow process of shedding the extra density they build up over years of supporting your weight against Earth's pull. All of this happens gradually, peacefully, without drama or discomfort. It's adaptation in its purest form. Life finding a way to thrive in conditions that would have seemed impossible just hours before. Your body, that remarkable product of millions of years of evolution, is proving its flexibility, its ability to rewrite its own rules when the environment demands it. When you wake on your second day in space, you'll find that the disorientation has lessened. Your brain is already beginning to create new maps of up and down, new ways of understanding your position in three-dimensional space. The puffy feeling in your face might be a little more pronounced, but it's becoming your new normal, as natural as the feeling of gravity once was. You're no longer a visitor to this environment. You're becoming a resident of space, and your year-long transformation has truly begun. Each day will bring new changes, new adaptations, new ways of being human in a place where humans were never meant to live. And yet, amazingly, beautifully, your body is proving that it can call anywhere home, given enough time and patience. This is just the beginning of your story, the first chapter of a year-long conversation between your earthly biology and the infinite cosmos that surrounds you. As we continue this journey together, we'll explore each change, each adaptation, each remarkable transformation that makes extended space travel not just possible, but a testament to the incredible resilience and flexibility of life itself. For now, let yourself float in this moment of transition, suspended between worlds, beginning a journey that will change you in ways both profound and gentle. Close your eyes and imagine yourself there, weightless and free, surrounded by the vast peace of space, your body beginning its slow, beautiful dance with the cosmos. As your second week in space unfolds, something profound and quietly beautiful begins to happen to your body. The initial wonder of weightlessness has settled into a new kind of normal, and now the deeper conversation between your earthly biology and the cosmos begins in earnest. This is where the real transformation starts, not with dramatic changes or sudden shifts, but with the gentle, persistent whisper of adaptation that touches every cell, every fiber, every system in your floating form. Picture yourself now, 2 weeks into this extraordinary journey, as you wake in your sleeping compartment. The process of waking itself has become something entirely new. On Earth, consciousness would gradually return as your body registered the weight of blankets, the pressure of a mattress against your back, the gentle pull of gravity encouraging you to stay horizontal just a little longer. Here, awakening is like surfacing from the depths of the most peaceful dream, where your body floats in perfect suspension, neither pulled nor pushed, existing in a state of perfect equilibrium with the space around you. Your arms drift gently in front of you as consciousness returns, and you notice something that would have seemed magical just weeks ago, but now feels as natural as breathing. Your limbs have found their own preferred position in microgravity, a gentle, relaxed pose that biomechanics experts call the neutral body posture. Your knees are slightly bent, your arms float comfortably in front of your chest, your spine has assumed a gentle curve that relieves all pressure from the vertebrae. You look and feel like someone floating peacefully in the perfect swimming pool, except the water is invisible and offers no resistance to your movements. This position isn't something you've consciously chosen. Instead, it's your body's own wisdom asserting itself, finding the configuration that requires the least energy, the least muscular effort to maintain. Your muscles, those complex bundles of fibers that have spent your entire life working against gravity's constant downward pull, are beginning to discover what it means to truly relax for the first time since you took your first breath on Earth. But this relaxation comes with its own subtle consequences, changes so gradual and gentle that you might not notice them from day to day, but which accumulate over weeks into something profound. Your muscles, you see, are remarkably adaptable. They grow stronger when asked to work harder, and they grow more efficient when their workload decreases. In the absence of gravity, many of your muscle groups are finding themselves with significantly less to do. Consider your calf muscles, those powerful engines that have propelled you through countless steps across Earth's surface. For every day of your life before this journey, they contracted and relaxed with each step, lifting your entire body weight against gravity's pull thousands of times per day. Now, they're discovering what it feels like to rest, to exist without that constant demand for power. The change is so gradual that you don't feel weak or different. Instead, you feel relaxed, as if you've been carrying tension in these muscles for decades without realizing it. Your quadriceps, those large muscles in the front of your thighs that have helped you stand up from chairs, climb stairs, and support your weight during countless hours of standing. They too are beginning their gentle adaptation to this new reality. The fibers within these muscles, built up over years of resistance training against Earth's gravitational field, start to realize that their current strength is more than adequate for the gentle movements required in space. This process of muscular adaptation doesn't happen overnight, and it doesn't happen with any discomfort or dramatic change. Instead, it unfolds like the changing of seasons, so slowly that you don't notice it happening, but so thoroughly that over time it becomes unmistakable. Your muscles are becoming more efficient, shedding the extra bulk and power that were necessary for life under gravity, but are now excess capacity in your weightless world. The beautiful thing about this process is how your body manages it. You don't suddenly become unable to move or control your limbs. Instead, your movements become more fluid, more graceful, requiring less effort and energy. When you push off from a wall to glide across your spacecraft, the movement comes from a gentle engagement of muscles that no longer have to work against their own weight. It's like learning to write with a pen that weighs nothing, or learning to dance with a partner who follows your every movement perfectly. Your back muscles, in particular, are experiencing something unprecedented. These complex networks of muscle fibers have spent your entire life holding your spine erect against gravity's pull, maintaining your posture through hours of sitting, standing, and moving through your earthbound life. Now, they're discovering what it means to exist without that constant load. Your spine floats in its own perfect alignment, supported not by muscular effort, but by the balanced tension of ligaments and the natural structure of your vertebrae. This release of chronic muscular tension brings with it a sensation that's difficult to describe to someone who has never experienced it. It's like taking off shoes that were slightly too tight, but you'd worn them for so long that you'd forgotten what comfortable feet felt like. Except in this case, it's your entire musculoskeletal system discovering comfort it never knew was possible. As the weeks pass, you begin to notice that your movements in space have taken on a quality that can only be described as graceful. When you need to turn around, you don't pivot on your feet as you would on Earth. Instead, you might gently touch a wall with your fingertips and allow your body to rotate slowly around your center of mass. The movement is smooth, controlled, effortless in a way that earthbound movement never quite achieves. Reaching for objects becomes an art form. Instead of the quick, decisive movements you might use on Earth, you learn to move with patience and precision. Push too hard, and you'll send both yourself and the object floating in opposite directions. But apply just the right amount of force, with just the right timing, and you can pluck a floating tool out of the air with the delicacy of a dancer or the precision of a surgeon. Your fingers and hands, meanwhile, are adapting to this new reality in their own subtle ways. The small muscles in your hands and forearms that have spent years gripping against gravity's attempt to pull things from your grasp are finding that they need to work differently now. Objects don't fall from your hands in space. They float away, but slowly enough that you can usually catch them again if you're attentive. This change in how you interact with objects transforms even the simplest tasks into something almost meditative. Eating becomes a slow, mindful process as you guide food to your mouth and ensure that crumbs don't escape to float around your living space. Drinking requires a new kind of attention as you coax liquid from containers designed to work in zero gravity. Every interaction with the physical world becomes more deliberate, more conscious, more connected. Your core muscles, those deep stabilizing muscles around your trunk that have worked constantly to maintain your balance and posture on Earth, are also adapting to their new role. Instead of fighting against gravity to keep you upright, they're learning to make the tiny adjustments needed to control your orientation and movement in three-dimensional space. It's a different kind of work, more like the subtle muscular control a gymnast uses on the balance beam, but even more refined. This adaptation of your core muscles contributes to a fascinating change in how you perceive and control your body in space. You develop what astronauts often describe as a three-dimensional body awareness that's impossible to achieve on Earth. You learn to sense not just where your limbs are in relation to your trunk, but where your entire body is positioned in relation to the walls, ceiling, and floor of your spacecraft. though these distinctions become increasingly meaningless as you become more comfortable with true three-dimensional living. The process of muscular adaptation extends beyond just the large, obvious muscle groups. The tiny muscles in your inner ear that help maintain balance and spatial orientation are working overtime to make sense of this new environment. They're receiving conflicting information. Your eyes tell you one thing about your position and movement, while the fluid-filled chambers of your inner ear, no longer oriented by gravity, tell you something entirely different. Your brain, that remarkable organ of adaptation, is working tirelessly to resolve these conflicts and create a new understanding of spatial relationship and movement. It's like learning a new language, but instead of words and grammar, you're learning new ways to interpret the signals your body sends about where you are and how you're moving through space. This neurological adaptation happens gradually, almost imperceptibly. One day, you realize that you no longer feel disoriented when you wake up in your sleeping bag. Another day, you notice that you've stopped reaching for handholds before pushing off from a wall. Your body has learned to trust its ability to control movement in this weightless environment. Your brain has written new software for existing in 3 dimensions, and it's running in the background of your consciousness like the most sophisticated autopilot imaginable. The cardiovascular system, that network of heart and vessels that has spent your lifetime pumping blood against gravity's pull, is also beginning its own quiet adaptation. Your heart, no longer required to work as hard to pump blood from your legs back up to your chest and brain, starts to beat with a slightly different rhythm. It's not dramatic. You don't feel your heart rate change noticeably. But over time, your cardiovascular system becomes more efficient at maintaining circulation in this gravity-free environment. This cardiovascular adaptation brings with it some interesting changes in how you feel from day to day. Many astronauts report feeling more energetic in space, as if they're operating on less caffeine, but feeling just as alert and capable. This might partly be due to the reduced workload on the heart and circulatory system, freeing up energy that was previously devoted to the constant work of pumping blood against gravity. Your blood itself is beginning to change as well, though these changes are happening at a cellular level that you can't directly perceive. Without gravity to help settle different components of your blood, your circulatory system begins to adjust the composition and behavior of this vital fluid. Red blood cells, platelets, and plasma all begin subtle adaptations to their new environment, changes that will become more pronounced as your year in space continues. As you float through your daily routines in these early weeks, you might notice that tasks which required significant physical effort on Earth now seem almost effortless. Moving large objects that would have required considerable strength on Earth can now be accomplished with gentle pushes and patient maneuvering. It's not that the objects have become lighter. Mass remains the same in space, but without weight, without gravity pulling them toward a floor, they can be moved and positioned with remarkable ease. This transformation in how you relate to physical objects extends to how you relate to your own body. You begin to think of yourself less as a vertical being designed to stand upright on a surface, and more as a three-dimensional entity capable of moving and orienting in any direction. Your body becomes not just a vehicle for consciousness, but a spacecraft itself, perfectly designed for navigation through this weightless realm. The changes happening to your bones during this period are perhaps the most profound, though they occur so gradually that you have no direct awareness of them. Your skeleton, that remarkable framework that has supported your body against gravity for your entire life, is beginning to realize that it no longer needs to be quite so dense, quite so robust. Like a building that discovers it no longer needs to support as much weight, your bones begin the slow process of becoming more efficient for their new environment. This bone remodeling is happening at the cellular level, as osteoblasts and osteoclasts, the cells responsible for building and breaking down bone tissue, adjust their activity to match the reduced mechanical stress of weightless living. It's a process as natural as the way bones strengthen in response to weight-bearing exercise on Earth, but in reverse, and it happens with the same gradual patience that characterizes all of your body's adaptations to space. Throughout all of these changes, Perhaps the most remarkable thing is how normal they feel as they're happening. You don't wake up each morning feeling dramatically different from the day before. Instead, the changes accumulate gradually, like the way you might slowly adjust to living in a different climate. One day, you realize that you've been effortlessly floating in positions that would have required significant muscular effort to maintain on Earth. Another day, you notice that your movements have taken on a fluid quality that feels as natural as walking once did. This gradual adaptation is your body's wisdom at work. The same biological intelligence that allows you to adjust to changes in temperature, altitude, or activity level. Your body doesn't fight against the new environment. Instead, it embraces it, finding ways to thrive and function optimally in conditions that evolution never specifically prepared it for. It's a testament to the remarkable flexibility and resilience of human biology, this ability to not just survive, but flourish in an environment so different from the one that shaped our species. As you settle into sleep at the end of another day in this weightless world, your body continues its quiet work of adaptation. Your muscles relax into their new preferred positions. Your cardiovascular system maintains its gentle circulation. Your bones continue their cellular conversation about density and strength. All of this happens without your conscious intervention, guided by biological processes refined over millions of years of evolution. In your dreams, you might find yourself moving through space with increasing confidence and grace. Your sleeping mind processes the day's experiences of weightless movement, integrating them into your growing understanding of how to be human in this impossible place. You dream of floating, of gliding, of moving through three-dimensional space with the ease of thought itself. And when you wake tomorrow, you'll be subtly but unmistakably different from the person who went to sleep, more adapted, more comfortable, more at home in this realm. Between worlds, your body continues its patient transformation, becoming day by day more perfectly suited to life among the stars. As your first month in space draws to a close, you begin to notice changes that are both subtle and profound, transformations that speak to one of the most fundamental aspects of human biology, the way fluids move through your body. On Earth, you never gave much thought to how blood, lymph, and other bodily fluids distributed themselves throughout your tissues. Gravity was the invisible choreographer of this internal dance, pulling fluids downward, creating gradients and pressures that your body had learned to work with over millions of years of evolution. But now, in the gentle embrace of microgravity, these fluids are learning new patterns, new rhythms, new ways of flowing through the landscape of your body. It's like watching a river suddenly freed from the constraints of its banks, finding new channels and creating new patterns as it flows across a transformed terrain. The most noticeable change appears in your face, and it's one that gives you and your crewmates a particular kind of gentle, well-rested appearance. Your face has become slightly puffy, not in an uncomfortable or unhealthy way, but rather as if you've been enjoying the most restful sleep of your life for weeks on end. Your features have softened, rounded slightly, giving you an almost cherubic quality that's both endearing and fascinating to observe. This facial swelling is the result of what space medicine calls fluid shift, a process as natural and inevitable as water finding its level, but happening within the three-dimensional container of your body. On Earth, gravity encouraged the fluids in your body to pool in your lower extremities throughout the day. Your legs and feet would swell slightly by evening, a process so normal that you probably never paid it much attention. Your heart worked constantly to pump blood back up from your feet to your chest, fighting against gravity's pull with every beat. Now, without gravity's downward pull, these fluids are free to distribute themselves more evenly throughout your body. But evenly, in microgravity, doesn't mean the same distribution you had on Earth. Instead, fluids tend to shift toward your chest and head, creating a redistribution that's both fascinating and remarkably comfortable once your body adjusts to it. The process happens gradually, over days and weeks, like the slow redistribution of sand in an hourglass that's been turned on its side. You don't feel it happening moment by moment. but over time you begin to notice the changes. Your face in a mirror looks different. Not worse, not better, just different. Your features are softer, your complexion perhaps slightly more flushed, as if you've been spending time in a gentle, warm breeze. Your crewmates undergo the same transformation, and there's something almost magical about watching familiar faces take on this new quality. It's as if everyone has been touched by the same benevolent spell, made slightly more peaceful, more serene, more at rest than they ever appeared on Earth. The sharp edges of terrestrial living, the subtle signs of stress, fatigue, and the constant work of existing under gravity begin to soften and fade. This fluid redistribution affects more than just your appearance. Inside your chest, your heart is adapting to receiving a greater volume of blood than it's accustomed to. On Earth, a significant portion of your blood volume was typically pooled in your legs and lower body, requiring your heart to work harder to maintain circulation. Now, with more blood available in your central circulation, your heart begins to adapt to this new abundance. The adaptation is gradual and comfortable. Your heart doesn't suddenly start racing or struggling. Instead, it begins to beat slightly more efficiently, like an engine that's been tuned to work with a richer fuel mixture. Over time, you might notice that your resting heart rate has dropped slightly, not because you're becoming less fit, but because your cardiovascular system is becoming more efficient at its job in this new environment. Your kidneys, those remarkable organs that filter your blood and maintain the delicate balance of fluids and electrolytes in your body, are also adapting to this new distribution of fluids. They're receiving more blood flow than they're accustomed to, and they respond by adjusting their filtering and processing activities. It's like upgrading a water treatment plant to handle a greater volume of water. The system adapts to maintain the same high quality of output while processing more input. This adaptation of your kidneys leads to some interesting changes in your daily routine. You might find yourself needing to urinate more frequently in your first weeks in space, as your kidneys work to process the increased blood flow and help your body find its new fluid balance. It's not uncomfortable, just different, like your body is fine-tuning itself to work optimally in its new environment. The lymphatic system, that often overlooked network of vessels and nodes that helps maintain fluid balance and supports your immune system, is also undergoing its own quiet revolution. On Earth, lymphatic fluid relied partly on gravity and partly on muscle contractions to move through its vessels. In microgravity, this system has to learn new ways to maintain its circulation, developing new patterns of flow that work without gravity's assistance. This adaptation of your lymphatic system contributes to the overall sense of well-being that many astronauts report in space. The lymphatic system plays a crucial role in removing waste products and toxins from your tissues, and its adaptation to microgravity often results in improved efficiency. It's as if your body's internal cleaning system has been upgraded, working more effectively to maintain the health and balance of your tissues. The fluid changes extend to your eyes as well, though these adaptations are so subtle that you might not notice them directly. The tiny blood vessels in your eyes are responding to the changed fluid pressures, adapting to maintain optimal vision in your new environment. Some astronauts report that colors seem slightly more vivid in space, though this might be due to a combination of factors, including the pristine atmosphere of the spacecraft and the remarkable views of Earth and space that surround you. Your sinuses, too, are part of this fluid reorganization. On Earth, gravity helped drain your sinuses, keeping them clear and comfortable. In space, sinus drainage works differently, sometimes leading to a sensation similar to having a very mild head cold. It's not uncomfortable, more like the feeling you might have at the beginning of a cold, when your sinuses are just slightly congested but not painful or troublesome. This sinus congestion can affect your sense of smell and taste in interesting ways. Many astronauts report that food tastes different in space, not necessarily worse or better, but changed. Part of this is due to the way scents behave in microgravity. Without convection currents driven by gravity, aromas don't rise and disperse the way they do on Earth. Combined with the mild sinus congestion, this creates a unique sensory experience that becomes part of your adaptation to space living. The saliva in your mouth is also affected by these fluid changes. Without gravity to help saliva flow naturally around your mouth and down your throat, it behaves differently, sometimes creating a slightly thicker sensation. It's not unpleasant, just another subtle reminder that every system in your body is adapting to this new environment. Perhaps most remarkably, your brain is also experiencing these fluid changes. The cerebrospinal fluid that bathes and protects your brain and spinal cord is redistributing itself in response to microgravity. This fluid normally drains downward along your spine, aided by gravity, but in space it must find new patterns of circulation. Your brain adapts to these changes with the same remarkable flexibility it shows in all aspects of space adaptation. Some researchers believe that these changes in cerebrospinal fluid circulation might contribute to the enhanced creativity and problem-solving abilities that many astronauts report in space. It's as if the brain, freed from some of the constraints of terrestrial fluid dynamics, is able to function with even greater efficiency and clarity. Whether this is due to the fluid changes, the unique environment of space, or the remarkable experience of living beyond Earth's atmosphere, the result is often a sense of mental clarity and focus that's difficult to achieve on Earth. The interstitial fluid, the fluid that exists between your cells throughout your body, is also finding new patterns of distribution. This fluid plays a crucial role in delivering nutrients to your cells and carrying away waste products. In microgravity, without gravity's influence on this delicate transport system, your cells are experiencing a different environment for nutrient exchange and waste removal. This change in interstitial fluid dynamics might contribute to the sense of vitality and well-being that many astronauts experience in space. It's as if your cells are receiving room service instead of having to rely on a more complex delivery system. The efficiency of cellular nutrition and waste removal improves, contributing to the overall sense that your body is functioning at a higher level of optimization. Your skin, that largest organ of your body, is also responding to these fluid changes. With improved fluid circulation and the absence of gravity's constant pull, your skin often takes on a healthier, more vibrant appearance in space. The improved circulation brings more nutrients to your skin cells and helps remove waste products more efficiently. Many astronauts report that their skin looks and feels better in space than it did on Earth, as if they've been receiving the world's most effective spa treatment. The mucous membranes throughout your body, in your nose, mouth, throat, and other areas, are also adapting to the changed fluid dynamics. These tissues, which rely on proper fluid balance to function optimally, often become more efficient at their protective and filtering functions in the improved fluid environment of space. As weeks pass, you begin to notice that these fluid changes have created a new baseline for how your body feels and functions. The initial puffiness in your face becomes your new normal, and you might find that you prefer how you look and feel with this gentle fluid redistribution. Your body has found a new equilibrium, a new way of managing its internal fluid dynamics that's perfectly suited to life in microgravity. This adaptation extends to your body's temperature regulation as well. On Earth, gravity affects how your blood circulates near your skin's surface, influencing how effectively you can cool yourself through perspiration and blood vessel dilation. In space, with improved circulation and different fluid dynamics, your body's temperature regulation system becomes more efficient, often leading to a more comfortable and stable body temperature throughout the day. The hormonal systems that regulate fluid balance in your body are also adapting to this new environment. Your adrenal glands, which produce hormones that help regulate blood pressure and fluid balance, are learning to work with the new fluid dynamics of space. Your pituitary gland, which produces antidiuretic hormone to help control water retention, is also adjusting its output to match your body's new needs. These hormonal adaptations happen gradually and naturally, like a complex orchestra gradually tuning itself to play in a new key. Each system adjusts its contribution to maintain the overall harmony of your body's function, creating a new symphony of physiological balance that's perfectly suited to your weightless environment. The changes in fluid distribution also affect your sleep in subtle but important ways. On Earth, lying down for sleep allowed fluids that had pooled in your legs during the day to redistribute throughout your body. In space, since fluids are already more evenly distributed, sleep becomes a different kind of rest. Less about physical recovery from gravity's effects and more about mental and cellular restoration. Many astronauts report that their sleep in space, once they've fully adapted to the environment, is deeper and more restful than sleep on Earth. It's as if your body, freed from the constant work of managing fluid distribution against gravity, can devote more of its resources to the restorative processes that happen during sleep. As you float in your sleeping compartment, your body continues its quiet work of fluid management and optimization. Your circulatory system maintains its new patterns of flow. Your lymphatic system continues its enhanced cleaning and maintenance activities, and your cellular fluid exchange continues at its improved level of efficiency. In your dreams, you might find that you're swimming through environments that feel perfectly natural and comfortable. Your sleeping mind processes the new sensations of improved fluid dynamics, integrating them into your growing understanding of what it means to be human in this transformed state. You dream of floating in perfect comfort, of breathing with unprecedented ease, of existing in a state of optimal fluid balance that feels like the most natural thing in the world. When you wake, you're greeted by the familiar sight of your slightly puffy but peaceful face in the mirror, a gentle reminder of the remarkable adaptation your body has undergone. You've become a being perfectly suited to life in the fluid dynamics of space. Your every system optimized for this new environment where up and down have lost their meaning and where your body's fluids flow in patterns that evolution never specifically designed but that work beautifully nonetheless. This fluid shift is more than just a physiological adaptation. It's a transformation that touches every aspect of your existence in space, from how you look and feel to how efficiently your body functions at the cellular level. It's a reminder of the remarkable plasticity of human biology, the way life finds new ways to thrive in environments that seem impossible, creating new forms of health and vitality that were previously unimaginable. As you move through your second month in space, something profound and beautiful is happening deep within your bones, a transformation so gradual and peaceful that you have no direct awareness of it occurring. If you could shrink down to the microscopic level and swim through the intricate architecture of your skeleton, you would witness one of the most remarkable examples of biological adaptation taking place in the cosmos. Your bones, those seemingly solid pillars that have supported your earthly existence, are not the static, unchanging structures they might appear to be. They're living tissue, as dynamic and responsive as any other part of your body, constantly rebuilding and reshaping themselves in response to the demands placed upon them. On Earth, these demands came primarily from gravity, that constant, gentle, but insistent force that required your skeleton to be dense, strong, and robust enough to support your weight through decades of standing, walking, running, and simply existing in a world that constantly pulls downward. But now, in the weightless cathedral of space, your bones are discovering that they no longer need to be quite so dense, quite so heavily mineralized. Like a coral reef that grows thick and strong in turbulent waters, but becomes more delicate in calm lagoons, your skeleton is beginning a slow, peaceful process of optimization for its new environment. This process is called bone remodeling, and it's happening at the cellular level throughout your skeleton. Imagine your bones as living cities, populated by two types of cellular inhabitants working in careful balance. The osteoblasts are the builders, constantly laying down new bone material, depositing calcium and phosphorus in precise crystalline patterns that create the remarkable strength and lightness of healthy bone tissue. The osteoclasts are the renovators, carefully dissolving old or unnecessary bone material to make room for new construction. On Earth, these two types of cells worked in response to the mechanical stress that gravity placed on your bones. Every step you took, every time you stood up or sat down, Every movement that required your skeleton to bear weight sent signals through your bones, telling the osteoblasts where to build and the osteoclasts where to clear away. It was a conversation conducted in the language of physics and chemistry, with stress and strain acting as the vocabulary that kept your bones strong and properly maintained. In space, this conversation has taken on a different tone. Without the constant mechanical loading that gravity provided, your osteoclasts have become more active relative to your osteoblasts. They're working with the same patient efficiency they always have, but now they're removing slightly more bone material than is being replaced. It's not a destructive process. It's optimization, your body's wise decision to reduce unnecessary density in an environment where that density is no longer required. If you could observe this process happening in real time, it would look like the most delicate, slow-motion sculpture being carved from living crystal. The osteoclasts move through your bone tissue like gentle waves, dissolving tiny amounts of calcium phosphate and other minerals with exquisite precision. They don't remove bone randomly or carelessly. Instead, they work according to patterns that reflect the new stress patterns of your weightless existence. The calcium and phosphorus that are released from your bones don't simply disappear. They enter your bloodstream, where they become available for other uses throughout your body. Your kidneys work to filter out the excess, while other systems in your body make use of these newly available minerals. It's a kind of biological recycling, where resources that were stored in your skeleton for structural purposes are being redistributed for other metabolic needs. This process affects different bones in different ways, reflecting the specific roles they played in your earthbound existence. The bones of your legs and hips, which bore the greatest load during walking and standing, undergo the most significant changes. Your femur, that strong pillar that connected your hip to your knee and supported your weight through countless steps, begins to shed some of its density in the areas where weight-bearing stress was greatest. Your spine, too, participates in this gentle transformation. The vertebrae that have spent decades compressed together by the weight of your upper body begin to experience a different kind of existence. Without the constant loading that shaped their dense, weight-bearing architecture, they start to optimize themselves for the new reality of weightless living. But perhaps the most fascinating aspect of this bone remodeling is how it reflects the remarkable intelligence of your body's adaptation systems. Your bones don't simply become uniformly less dense. Instead, they remodel themselves according to the new patterns of stress and use in your space environment. Areas that still experience mechanical loading, where muscles attach, where you push off from walls, where you grip handholds, maintain their strength and density. It's as if your skeleton is becoming a more specialized tool, perfectly adapted for the specific requirements of weightless existence. The process is so gradual that it unfolds over months, not days or weeks. If you were to take X-rays of your bones over the course of a year in space, you would see the changes accumulating slowly, like watching a time-lapse video of erosion shaping a landscape, but gentler, more purposeful, more beautiful in its precision. Your ribs, those curved protectors of your heart and lungs, also participate in this remodeling process. On Earth, they needed to be strong enough to protect your organs while also being flexible enough to expand and contract with each breath. In space, they maintain their protective function while optimizing their density for the reduced gravitational stress. The result is often an improvement in the ease and efficiency of breathing, as your rib cage becomes more flexible and responsive. The small bones of your hands and feet undergo their own specific adaptations. These complex structures, which on Earth needed to be robust enough for gripping and supporting body weight, begin to remodel themselves for the more delicate manipulations required in space. Your hands, in particular, become more sensitive and dexterous as the bones within them optimize for the precise movements needed to work with tools and equipment in microgravity. Your skull, that protective helmet for your brain, experiences minimal changes because it was never primarily a weight-bearing structure. This selectivity in bone remodeling demonstrates the remarkable specificity of your body's adaptation systems, changing what needs to change while preserving what needs to remain constant. The jawbone presents an interesting case study in this process. On Earth, the constant forces of chewing, biting, and speaking provided mechanical loading that maintained bone density. In space, where food is often softer and requires less aggressive chewing, the jawbone may undergo slight remodeling, becoming more efficient for the reduced mechanical demands of space eating. As this bone remodeling progresses, you might notice some subtle changes in how your body feels and moves. Your movements may become even more fluid and graceful as your skeleton sheds unnecessary density. You might feel lighter not just because of the absence of gravity, but because your bones themselves are becoming more perfectly suited to weightless existence. The calcium that's released from your bones during this process sometimes creates interesting effects elsewhere in your body. Some astronauts report changes in their hair and nails, which may grow differently as they receive this additional supply of calcium and other minerals. Your teeth, too, might benefit from the increased mineral availability in your bloodstream. Your body's systems for managing calcium balance are working overtime to process this increased mineral load. Your parathyroid glands, tiny organs near your thyroid that regulate calcium levels, are constantly monitoring and adjusting their hormone production to maintain proper calcium balance in your blood. Your intestines adjust their calcium absorption, your kidneys modify their calcium filtering, and your entire endocrine system fine-tunes itself to work with the new mineral dynamics created by bone remodeling. This process of bone adaptation is closely connected to the changes happening in your muscles. As your muscles adapt to the reduced workload of weightless living, they place less mechanical stress on the bones they're attached to. This reduced muscle loading contributes to the signals that tell your bones they can safely reduce their density. It's a coordinated adaptation, with your musculoskeletal system working as an integrated unit to optimize itself for space living. The remarkable thing about this bone remodeling is how it reflects the fundamental adaptability of life. Your skeleton, built over millions of years of evolution to function under Earth's gravity, is proving capable of reshaping itself for an environment that evolution never anticipated. It's a testament to the flexibility built into biological systems, the capacity for life to find new ways to thrive in conditions that seem impossible. Some of the most fascinating research in space medicine focuses on understanding exactly how bones know when and where to remodel themselves. Scientists believe that bone cells can sense mechanical stress through tiny fluid movements within the bone tissue itself. When these fluid movements change, as they do in microgravity, the cells respond by adjusting their building and renovation activities. It's like a hydraulic communication system built into your skeleton, more sensitive and responsive than any human-made monitoring system. The mineral crystals within your bones are also adapting to space conditions. These crystals, primarily made of calcium phosphate in a form called hydroxyapatite, may change their size and orientation in response to the altered mechanical environment. These microscopic changes contribute to the overall adaptation of your skeleton, creating bone tissue that's perfectly optimized for weightless living. Your bone marrow, that soft tissue within your bones where blood cells are produced, is also affected by these changes. As your bones remodel themselves, the spaces within them where marrow resides may change shape and size. Your bone marrow adapts to these new configurations while continuing its vital work of producing red blood cells, white blood cells, and platelets. It's another example of how your body maintains its essential functions even while undergoing profound structural changes. The process of bone remodeling in space has provided scientists with unprecedented insights into how bone health works on Earth. By studying how bones adapt to weightlessness, researchers have developed better treatments for osteoporosis and other bone diseases. Your experience in space is contributing to medical knowledge that will benefit people on Earth for generations to come. As you float through your daily routines in space, your bones continue their quiet work of adaptation. With each passing day, they become more perfectly suited to your weightless environment, more efficient in their structure, more optimized for the unique demands of space living. The process is so gradual and natural that you don't feel it happening, but over the months of your space residence, your skeleton is being transformed into something that has never existed before in the history of life on Earth. A human skeleton perfectly adapted for existence among the stars. In your sleep, as you float peacefully in your sleeping compartment, your bones continue their patient remodeling. Osteoclasts and osteoblasts work through the night, reshaping your skeleton cell by cell, crystal by crystal, creating new patterns of strength and lightness that reflect your transformed existence. You dream of floating through space with perfect ease, and while you sleep, your bones are making those dreams more real by adapting themselves to make weightless movement even more natural and effortless. When you wake each morning, you're supported by a skeleton that's become slightly more adapted to space, slightly more optimized for weightless living, slightly more perfect for your life among the stars. It's a transformation as beautiful and profound as any in nature, happening slowly and peacefully within you as you continue your remarkable journey through the cosmos. As you drift through your third month in space, floating peacefully in the gentle hum of your spacecraft's life support systems, something extraordinary is happening within your chest. Your heart, that tireless muscle that has beaten steadily since before you were born, is learning to dance to a new rhythm, adapting with remarkable grace to the transformed world of microgravity. For your entire life on Earth, your heart worked against gravity's constant pull, pumping blood upward from your feet through your legs, up through your torso, and into your brain against a force that never rested, never paused, never gave your cardiovascular system a moment's reprieve. Every beat was an act of defiance against the downward pull that sought to pool your blood in your lower extremities. Your heart was like a dedicated gardener, constantly working to water the topmost branches of the tree that was your body. But now, in the weightless cathedral of space, your heart is discovering what it means to work in perfect hydraulic balance. Without gravity to fight against, without the need to pump blood upward through the vertical landscape of your earthbound body, your cardiovascular system is experiencing a kind of freedom it has never known. It's like a river that has suddenly found itself flowing across perfectly level ground, able to move with an efficiency and ease that was previously impossible. The changes begin subtly, so gradually that you don't notice them day by day, but accumulate over weeks into a transformation that touches every aspect of how blood moves through your body. Your heart, that four-chambered marvel of biological engineering, starts to beat with a different quality. Not faster or slower necessarily, but more efficiently, with a rhythm that reflects the reduced workload of circulating blood in a gravity-free environment. Picture your heart as it adapts to this new reality. The left ventricle, that powerful chamber that has spent your lifetime contracting forcefully to send oxygenated blood up through your aorta and out to every corner of your body, begins to realize that it no longer needs to work quite so hard. Without gravity pulling blood away from your brain and upper body, circulation becomes easier, more effortless, like switching from pumping water uphill to pumping it across level ground. This adaptation happens gradually, as your heart muscle begins to optimize itself for the reduced workload. Just as any muscle becomes more efficient when it doesn't need to work against unnecessary resistance, your heart starts to develop a new relationship with the work of circulation. The muscle fibers within your heart walls may become slightly more refined, more precisely tuned for the specific demands of space circulation. Your blood pressure, too, begins its own gentle adaptation to this new environment. On Earth, your body maintained different pressures in different parts of your circulatory system to ensure that blood could flow against gravity's pull. Your blood pressure was higher in your arteries near your heart and gradually decreased as blood traveled through your body, with complex regulatory mechanisms ensuring that blood could reach even your highest extremities. In space, these pressure gradients begin to change, without gravity creating the need for high pressure to push blood upward. Your cardiovascular system can operate more efficiently at slightly lower pressures throughout. It's like a plumbing system that no longer needs to overcome the resistance of pumping water to high floors. The whole system can operate more gently while still delivering everything it needs to deliver. The arteries throughout your body are also adapting to this new pressure environment. These flexible tubes, which on Earth needed to be robust enough to handle the high pressures required for anti-gravity circulation, begin to optimize themselves for the gentler pressures of space circulation. They become more responsive, more sensitive to the subtle changes in blood flow that characterize your new cardiovascular reality. Your veins undergo perhaps the most dramatic adaptation. On Earth, these return pathways for your blood face the constant challenge of moving deoxygenated blood back to your heart against gravity's pull. Your leg veins, in particular, worked with a complex system of one-way valves and muscle contractions to push blood upward from your feet back to your heart. It was like a biological escalator, constantly working to move blood up through the vertical geography of your body. In space, your veins discover a new kind of ease. Without gravity working against them, blood returns to your heart much more easily, flowing smoothly through pathways that no longer need to fight an upward battle. The valves in your veins, those tiny biological check valves that prevented blood from flowing backward on Earth, find themselves with less work to do. The entire venous system becomes more efficient, like a return highway that suddenly has no hills to climb. This improved venous return has cascading effects throughout your cardiovascular system. Your heart receives blood more consistently and efficiently, which allows it to maintain circulation with less effort. The result is often a slight decrease in resting heart rate, not because you're becoming less fit, but because your heart is becoming more efficient at its job in this new environment. The capillaries throughout your body, those tiny vessels where the actual exchange of oxygen and nutrients takes place, also benefit from the improved circulation dynamics of space. Without gravity affecting the pressure gradients that drive blood through these microscopic pathways, capillary circulation often becomes more uniform and efficient. It's like upgrading from a sprinkler system that struggles to reach some areas to one that provides perfectly even coverage everywhere. This improvement in capillary circulation can have subtle but noticeable effects on how you feel day to day. Many astronauts report a sense of improved energy and mental clarity that may be partly due to the enhanced circulation delivering oxygen and nutrients more efficiently to tissues throughout the body. Your brain, in particular, benefits from the improved blood flow, receiving a more consistent supply of the oxygen and glucose it needs for optimal function. Your heart's electrical system, that remarkable network of specialized cells that coordinates the timing of each heartbeat, also adapts to the new conditions of space. On Earth, this electrical system had to coordinate with the mechanical challenges of pumping blood against gravity. In space, with reduced mechanical resistance, the electrical coordination of your heartbeat can become more refined, more precisely tuned. Some astronauts notice that they become more aware of their heartbeat in space, not because it's beating irregularly or problematically, but because the improved circulation and reduced background noise of cardiovascular strain makes the heart's rhythm more perceptible. It's like becoming aware of a clock ticking in a room where the background noise has suddenly been reduced. The clock isn't louder, but it's more noticeable in the quieter environment. The blood itself is also adapting to these new circulation patterns. Red blood cells, which carry oxygen throughout our body, are experiencing improved flow dynamics that allow them to move more efficiently through your circulatory system. The plasma, that liquid portion of your blood that carries nutrients, hormones, and waste products, also benefit from the improved circulation, creating more efficient transport of these vital substances throughout your body. Your body's systems for regulating blood pressure are also adapting to the space environment. The baroreceptors in your arteries, which normally sense pressure changes and signal your nervous system to adjust heart rate and blood vessel diameter, are learning to work with the new pressure patterns of space circulation. These sensors are recalibrating themselves, like instruments being adjusted to work in a new environment. The hormonal systems that control cardiovascular function are also part of this adaptation. Your adrenal glands, which produce hormones like adrenaline that affect heart rate and blood pressure, are adjusting their output to match the reduced cardiovascular demands of space living. The result is often a more stable, more relaxed cardiovascular state that contributes to the overall sense of well-being that many astronauts experience. As weeks pass, you may notice that physical activities that would have elevated your heart rate significantly on Earth now seem less demanding. Moving around your spacecraft, performing tasks, even exercising on the specialized equipment designed for space use. All of these activities place less strain on your cardiovascular system than similar activities would have on Earth. It's as if your heart has been given a performance upgrade, allowing it to handle the same workload with greater efficiency. The improved circulation also affects your body's temperature regulation. On Earth, your cardiovascular system worked with your body's cooling mechanisms to distribute heat and maintain stable body temperature. In space, with improved circulation and the absence of gravity's effects on blood flow, temperature regulation often becomes more efficient and stable. Many astronauts report feeling more comfortable temperature-wise, with less fluctuation between feeling too warm or too cool. Your sleep is also influenced by these cardiovascular adaptations. On Earth, the transition from standing or sitting to lying down involved significant changes in circulation as gravity's effects on blood flow shifted. In space, without these gravity-induced circulation changes, sleep can become deeper and more restorative. Your heart can maintain its efficient rhythm throughout the night without the variations in workload that characterized Earthbound sleep. The lymphatic system, which works closely with your cardiovascular system to maintain fluid balance and immune function, also benefits from the improved circulation dynamics of space. Lymphatic fluid moves more efficiently through its vessels, enhancing the body's ability to remove waste products and maintain tissue health. This improved lymphatic circulation contributes to the overall sense of vitality and well-being that characterizes successful adaptation to space. Perhaps most remarkably, your heart is also adapting to the emotional and psychological aspects of space living. The wonder, peace, and unique perspective that come with living among the stars seem to have a calming effect on cardiovascular function. Many astronauts report a sense of cardiovascular calm that goes beyond the purely physical adaptations, a deeper relaxation that comes from the profound experience of seeing Earth from space and living in the vast peace of the cosmos. As you float through your daily routines, your heart continues its quiet work of optimization. Each beat is slightly more efficient than it would have been on Earth. Each circulation cycle delivers its cargo of oxygen and nutrients with improved effectiveness. Each moment of cardiovascular function reflects your growing adaptation to life in space. The exercise equipment aboard your spacecraft allows you to maintain cardiovascular fitness while taking advantage of your heart's improved efficiency. Running on a treadmill in space, with your body held down by bungee cords, becomes a different kind of workout, one that can maintain your fitness while working with, rather than against, your body space adaptations. Your heart rate variability, the natural variation in time between heartbeats that's a sign of cardiovascular health, often improves in space. This improvement reflects not just the physical adaptations to microgravity, but also the reduced stress and improved autonomic nervous system function that many astronauts experience in the peaceful environment of space. During your exercise sessions, you might notice that your heart responds differently to physical exertion than it did on Earth. It can deliver the increased blood flow needed for exercise more efficiently, recover more quickly when exercise ends, and maintain stable function throughout a wider range of activities. It's like having a cardiovascular system that's been fine-tuned for optimal performance. The view of Earth from your spacecraft windows seems to have its own effect on cardiovascular function. Many astronauts report that looking at Earth from space, seeing the blue marble of their home planet floating in the cosmic dark, induces a profound sense of calm that they can feel in their heartbeat. It's as if the heart responds to the beauty and perspective of space with its own form of wonder. As you prepare for sleep each night, floating peacefully in your sleeping compartment, your heart settles into the gentle rhythm that will carry you through the night. Without the position changes and gravity-induced circulation shifts that characterize sleep on Earth, your heart can maintain its efficient space-adapted rhythm throughout the night, contributing to deeper, more restorative rest. In your dreams, you might find yourself moving with cardiovascular ease through environments of impossible beauty. Your sleeping mind processes the sensations of improved circulation, perhaps creating dreams of effortless movement, of flying with a lightness that feels completely natural, of existing in a state of perfect cardiovascular harmony. When you wake, your heart greets the new day with a steady, efficient rhythm it has developed for space living. Each beat reflects months of adaptation, optimization, and fine-tuning for life in the weightless realm. Your cardiovascular system has become something new, not quite earthly, not quite alien, but perfectly suited for your existence among stars. This cardiovascular adaptation is more than just a physiological change. It's a transformation that affects your entire experience of being alive in space. With improved circulation, enhanced efficiency, and the calm rhythm of a heart that has learned to work in perfect hydraulic balance, you're able to experience the wonder of space with a body that's perfectly adapted to call the cosmos home. As you float through your 4th month among the stars, gazing out through the pristine windows of your spacecraft at views that no earthbound human has ever witnessed, something subtle and fascinating is happening to your eyes. These remarkable organs, these windows to your soul that have served you faithfully throughout your earthly existence, are beginning their own quiet adaptation to the unique environment of space. It's a transformation as gentle as morning light gradually illuminating a landscape, affecting not just how your eyes function, but how you perceive and interact with the infinite cosmos that surrounds you. Your eyes, those intricate biological cameras that evolution perfected over millions of years for life on Earth, are discovering what it means to function in an environment where many of the assumptions they were built around no longer apply. The changes are subtle, often so gradual that you don't notice them happening, but they accumulate over weeks and months into something profound and beautiful, a new way of seeing that's perfectly suited to your life among the stars. The first changes begin with the fluid dynamics within your eyes themselves. Just as the fluid shift that affects your face and circulation also touches these delicate organs, the clear fluids inside your eyes, the aqueous humor that fills the space behind your cornea, and the vitreous humor that fills the larger chamber behind your lens, begin to behave differently in the absence of gravity's organizing influence. On Earth, these fluids maintain specific pressure gradients and circulation patterns that were shaped by gravity's constant downward pull. The aqueous humor, that crystal-clear fluid that nourishes your cornea and lens while maintaining the proper pressure inside your eye, flowed in predictable patterns that helped maintain optimal vision. In space, this fluid finds new patterns of movement, new ways of circulating that are often more efficient and effective than what was possible under gravity's influence. This change in fluid dynamics within your eyes can lead to subtle improvements in visual clarity. Many astronauts report that their vision seems sharper in space, colors more vivid, details more crisp. It's as if the optical system of your eyes has been fine-tuned, optimized for the perfect atmospheric conditions and improved fluid dynamics of your spacecraft environment. The muscles that control your eye movements are also adapting to the unique visual environment of space. On Earth, these muscles worked constantly to coordinate with your sense of balance and spatial orientation, making tiny adjustments to keep your vision stable as you move through a gravity-bound world. They collaborated closely with your inner ear to create the seamless visual experience that allowed you to walk, run, and move while maintaining clear, stable vision. In space, these eye muscles are learning new patterns of coordination. Without gravity providing a constant reference point for up and down, your eyes are developing new ways of tracking movement and maintaining visual stability. The extraocular muscles, those 6 tiny but powerful muscles that control each eye's movement, are becoming more sophisticated in their coordination, learning to work in 3 dimensions without the familiar gravitational reference point they relied on for your entire life. This adaptation of your eye muscles contributes to the enhanced spatial awareness that many astronauts develop in space. Your eyes learn to track objects moving in true three-dimensional space, following trajectories that would be impossible on Earth. You become able to visually follow a floating drop of water as it moves not just left and right, up and down, but in complex three-dimensional paths that curve and spiral through the air around you. The focusing mechanism of your eyes, that remarkable system of muscles and lens that allows you to shift your attention from nearby objects to distant ones, also undergoes its own adaptation to space living. On Earth, this system primarily worked in two dimensions, focusing on objects at various distances along horizontal and vertical planes. In space, you're learning to focus in true three-dimensional space, accommodating to objects that might be floating above you, below you, or at any angle in between. This three-dimensional focusing ability becomes particularly apparent when you're working with floating objects or tools. Your eyes learn to rapidly adjust focus as objects drift toward and away from you in a weightless environment, developing a kind of visual agility that's impossible to achieve on Earth. It's like learning to see in a new dimension, developing visual skills that are perfectly suited to life in microgravity. The retina, that light-sensitive tissue at the back of your eye that converts visual information into neural signals, is also experiencing the effects of improved circulation and reduced gravitational stress. The tiny blood vessels that nourish your retinal cells benefit from the enhanced circulation dynamics of space, often leading to improved retinal function and enhanced visual acuity. Some astronauts report that they can see fainter stars and more subtle details in the cosmic landscape around them, not just because of the pristine viewing conditions of space, but because their retinas are functioning more efficiently in the improved circulatory environment. It's as if the biological film in your eye's camera has become more sensitive, more capable of capturing the subtle gradations of light and shadow that characterize the space environment. The optic nerves that carry visual information from your eyes to your brain are also part of this adaptation process. These crucial pathways benefit from the improved circulation and reduced intracranial pressure that characterize space physiology. The result is often faster, more efficient transmission of visual information, contributing to the enhanced visual awareness and processing speed that many astronauts experience. Your brain's visual processing centers are also adapting to the new types of visual information you're experiencing in space. The visual cortex, that region of your brain that interprets the signals from your eyes, is learning to process images and movement patterns that have no earthly equivalent. You're seeing things that no human brain was evolutionarily prepared for. The curve of Earth's horizon, the diamond-bright stars unfiltered by atmosphere, the gentle dance of floating objects in three-dimensional space. This neurological adaptation happens gradually, as your brain builds new pathways and strengthens existing ones to better process the unique visual environment of space. You might notice that you're becoming more adept at judging distances and movements in three-dimensional space, more skilled at tracking multiple floating objects simultaneously, more capable of processing the complex visual information that characterizes life in microgravity. The way you perceive depth and distance is also changing in fascinating ways. On Earth, your brain used many visual cues to judge depth, the way objects overlap, how they change size with distance, the effects of atmospheric haze, and the subtle shadows cast by gravity-directed lighting. In space, many of these cues work differently or don't exist at all, so your brain is developing new strategies for depth perception. You learn to judge distances by the way light reflects off floating objects, by the subtle changes in their apparent motion, by the way they interact with the controlled lighting of your spacecraft. Your brain becomes remarkably good at estimating whether that floating screwdriver is 3 feet away or 6 feet away, whether that floating drop of water is moving toward you or away from you, whether that piece of equipment is within easy reach or requires a gentle push-off to intercept. The experience of looking out at Earth from space provides its own unique visual adaptation. The view of your home planet floating in the cosmic dark presents visual information that your eyes and brain have never had to process before. The brilliant blue and white marble of Earth against the absolute black of space creates contrast ratios and color combinations that don't exist in Earthbound experience. Your eyes adapt to process these extreme contrasts, becoming more sensitive to subtle variations in the Earthshine and the way sunlight illuminates different regions of the planet. You learn to see details in Earth's atmosphere, to track weather patterns from space, to observe the delicate interplay of light and shadow as the planet rotates beneath you. Your visual system becomes attuned to the rhythms of orbital day and night, the 90-minute cycle of sunrise and sunset that characterizes low Earth orbit. The complete absence of atmospheric distortion in space also affects how your eyes function. On Earth, you've never seen truly clear starlight. Every photon that reaches your eyes have been bent, scattered, and filtered by Earth's atmosphere. In space, you're seeing starlight in its pure form, and your eyes are adapting to process this unfiltered cosmic illumination. Stars appear as perfect points of light, their colors pure and undistorted. The Milky Way becomes a river of light across the sky with detail that's impossible to see from Earth's surface. Your eyes learn to appreciate these subtle differences, becoming more sensitive to the pure light of space and more capable of distinguishing the minute variations in stellar brightness and color that characterize the view from beyond Earth's atmospheric veil. The adaptation of your visual system also affects how you perceive motion in space. On Earth, motion was always relative to a gravitational reference frame. Things fell down, rose up, moved left or right across a stable horizontal plane. In space, motion is purely relative, with no absolute reference point except the distant stars themselves. Your eyes and brain learn to process this relative motion in new ways. You become expert at judging whether you're moving relative to your spacecraft, whether an object is floating toward you or away from you, whether you're rotating around one axis or another. Your visual system develops a kind of three-dimensional motion sensitivity that's impossible to achieve on Earth. Even the way you blink is affected by the space environment. On Earth, blinking served not just to lubricate your eyes, but also to clear away dust, pollen, and other particles that gravity and air currents brought into contact with your eyes. In the filtered, controlled atmosphere of your spacecraft, your eyes often need to blink less frequently, and when you do blink, it's a gentler, more relaxed action. The tear film that coats your eyes also behaves differently in microgravity. These thin layers of moisture that keep your eyes lubricated and clear don't drain away as quickly as they do on Earth, where gravity encourages tears to flow downward. Instead, they maintain a more stable coating over your eyes, often leading to improved comfort and clarity of vision. Some astronauts notice that their eyes feel more comfortable in space than they ever did on Earth. The combination of the clean spacecraft atmosphere, the stable tear film, and the reduced strain from gravitational effects creates an environment where eyes can function with remarkable comfort and efficiency. The color perception abilities of your eyes may also be enhanced in space. Without the filtering effects of Earth's atmosphere, and with the improved circulation and oxygenation that characterizes space physiology, the color-sensing cells in your retina often function more efficiently. You might notice that you can distinguish more subtle differences in color and hue, particularly in the amazing palette of blues, whites, and browns that characterize Earth as seen from space. Your night vision also adapts to the unique lighting conditions of space. The cycle of orbital day and night, with its rapid transitions between brilliant sunlight and deep space darkness, teaches your eyes to adapt more quickly between light and dark conditions. Your pupils learn to adjust more rapidly, and the rod cells in your retina that are responsible for low-light vision become more sensitive and responsive. During the dark portions of your orbit, when your spacecraft passes through Earth's shadow, you might find that you can see details of Earth's surface illuminated only by city lights, lightning flashes, or the aurora. Your adapted night vision allows you to appreciate the subtle beauty of your home planet in darkness, seeing patterns of human civilization and natural phenomena that are invisible from Earth's surface. The psychological effects of these visual adaptations are profound. As your eyes become more attuned to the visual environment of space, you develop a deeper appreciation for the beauty and wonder that surrounds you. The enhanced visual acuity, improved color perception, and three-dimensional visual awareness combine to create a visual experience that's richer and more nuanced than anything possible on Earth. Many astronauts describe a sense of visual awakening that occurs during their time in space, a feeling that they're seeing clearly for the first time, that their eyes have been opened to aspects of reality that were previously hidden. Whether this is due to the physiological adaptations of the visual system, the unique beauty of the space environment, or the profound psychological impact of seeing Earth from space, the result is often a transformed relationship with vision itself. As you float peacefully through your spacecraft, your adapted eyes taking in the impossible beauty of your surroundings, you're experiencing vision in a way that no earthbound human ever has. Your eyes have become space-adapted organs, perfectly tuned for life among the stars, capable of seeing wonders that exist nowhere else in human experience. In your sleep, as you drift in your sleeping compartment with your eyes closed, the visual processing centers of your brain continue their work of adaptation. You might dream in 3 dimensions more vividly than ever before, or find yourself dreaming of views and perspectives that could only exist in space. Your sleeping mind processes the day's visual experiences, integrating them into your growing understanding of what it means to see as a space-adapted human. When you wake and open your eyes to another day in space, you're greeted by a visual world that has become as familiar as any earthbound landscape ever was, but infinitely more beautiful. Your eyes have learned to call space home, to see with clarity and wonder in an environment where human eyes were never meant to function, creating new forms of beauty and understanding that exist only in the realm between worlds. As you glide through your 5th month in the weightless sanctuary of space, floating peacefully through routines that have become as natural as breathing, something profound and invisible is happening deep within your body at the most fundamental level of life itself. Your immune system, that vast and intricate network of cellular guardians that has protected you throughout your earthly existence, is undergoing its own quiet transformation, adapting with remarkable wisdom to the unique environment of your cosmic home. This adaptation happens in the hidden spaces of your body, in the microscopic realm where cells communicate through chemical whispers and molecular signals. It's a transformation so subtle that you have no direct awareness of it occurring, yet so comprehensive that it touches every aspect of how your body maintains health, fights off potential threats, and keeps the delicate balance of biological systems that sustain your life among the stars. Your immune system is perhaps the most complex and sophisticated defense network ever created by evolution. It's an army of specialized cells, each with its own role and responsibilities, working together in perfect coordination to distinguish between what belongs in your body and what doesn't, to repair damage, to fight infection, and to maintain the careful equilibrium that defines health. On Earth, this system evolved to function under gravity's influence, with circulation patterns, cell movement, and molecular transport all shaped by the downward pull that has been a constant throughout evolutionary history. In space, your immune system is discovering new ways to carry out its essential functions. The microgravity environment affects how immune cells move through your bloodstream and lymphatic system, how they communicate with each other, and how they respond to potential threats. It's like watching a well-rehearsed orchestra learn to play the same beautiful music in a completely different acoustic environment. The fundamental harmonies remain the same, but the performance takes on new qualities and subtleties. The white blood cells that patrol your bloodstream, like molecular sentries, are among the first to adapt to their new environment. These remarkable cells, which include lymphocytes, neutrophils, monocytes, and other specialized defenders, normally navigate through your circulatory system using a combination of blood flow, chemical gradients, and gravitational influences. In space, they're learning to move and function without gravity's organizing influence, developing new patterns of circulation and distribution throughout your body. Your lymphocytes, those crucial cells that include T cells and B cells responsible for immune memory and antibody production, are experiencing the enhanced circulation dynamics that characterize space physiology. The improved blood flow and more efficient lymphatic circulation often allows these cells to move more freely throughout your body, potentially creating more effective immune surveillance than was possible under Earth's gravitational constraints. The bone marrow, that soft tissue within your bones where many immune cells are produced, is also adapting to the space environment. As your bones undergo their gentle remodeling process, the spaces within them that house this vital immune cell factory are also changing. Your bone marrow continues its essential work of producing new immune cells, but it's doing so in the context of the altered bone structure and improved circulation that characterizes your space-adapted skeleton. Perhaps most fascinatingly, the lymph nodes throughout your body, those small, bean-shaped structures that act as filtering stations for your lymphatic system, are experiencing the benefits of improved lymphatic circulation and microgravity. On Earth, lymphatic fluid relied partly on gravity and muscle contractions to move through its vessels. In space, this system often becomes more efficient, allowing lymph nodes to process immune information and coordinate immune responses more effectively. Your spleen, that often overlooked organ that plays crucial roles in immune function and blood filtration, is also adapting to the space environment. Located in your upper left abdomen, your spleen benefits from the improved circulation and reduced gravitational stress that characterizes space physiology. This adaptation often results in enhanced immune function, as your spleen can more efficiently filter blood, process immune information, and coordinate with other parts of your immune system. The thymus gland, nestled behind your breastbone and responsible for training T cells to recognize threats, also experiences the benefits of the space environment. In the improved circulation and reduced stress environment of space, your thymus can often function more efficiently, potentially enhancing the education and deployment of T cells throughout your immune system. At the cellular level, the process of immune cell activation and communication is also affected by the space environment. Immune cells communicate through the release of chemical messengers called cytokines, and the patterns of cytokine production and distribution can change in microgravity. Often, these changes result in more balanced immune responses, with less of the excessive inflammation that can characterize immune function under the chronic stress of Earth's gravitational environment. Your body's ability to recognize and respond to foreign substances, what immunologists call antigen recognition, may also be enhanced in space. The improved circulation and cellular function that characterizes space adaptation can lead to more efficient presentation of antigens to immune cells, potentially resulting in faster and more effective immune responses when needed. The complement system, a group of proteins that enhance the ability of antibodies and immune cells to clear pathogens from your body, also adapts to the space environment. These proteins circulate in your blood and are activated in cascade fashion when threats are detected. In the improved circulation environment of space, the complement system often functions more efficiently, providing enhanced immune protection. Your skin, that largest organ of your body and first line of immune defense, undergoes its own adaptation to the space environment. With improved circulation and the absence of many environmental stressors present on Earth, your skin often becomes more effective at its immune functions. The specialized immune cells within your skin, including Langerhans cells and other dendritic cells, benefit from the enhanced circulation and can often provide more effective immune surveillance of your body's primary barrier to the external environment. The mucous membranes that line your respiratory and digestive tracts also experience immune adaptations in space. These tissues, which serve as important barriers against potential pathogens, often function more efficiently in the controlled environment of your spacecraft. The improved circulation and reduced stress environment can enhance the function of the immune cells embedded in these tissues, creating more effective immune barriers. Your gut-associated lymphoid tissue, GALT, which represents a huge portion of your body's immune system, also adapts to space living. The immune cells and structures associated with your digestive system benefit from the improved circulation and the carefully controlled diet and environment of space travel. This often results in enhanced immune function in one of your body's most important immune organs. The process of immune cell migration, how immune cells move from where they're produced to where they're needed, also changes in the space environment. Without gravity to influence cell movement patterns, immune cells often develop more direct and efficient migration routes through your tissues. It's like upgrading from transportation system with many traffic jams and detours to one with clear, efficient highways, allowing rapid deployment of immune resources where they're needed. Your body's inflammatory responses also adapt to the space environment. Inflammation is a crucial immune function that helps fight infection and promote healing, but chronic inflammation can be harmful. In the reduced stress environment of space, many astronauts experience a reduction in chronic inflammatory markers, suggesting that their immune systems are functioning in a more balanced, less reactive state. The production of antibodies, those Y-shaped proteins that recognize and neutralize specific threats, may also be enhanced in space. The B cells responsible for antibody production benefit from the improved circulation and enhanced cellular function that characterizes space adaptation. This can result in more efficient antibody production and potentially longer-lasting immune memory. Your body's natural killer, NK, cells, which are responsible for detecting and destroying abnormal cells, including cancerous ones, also adapt to the space environment. These important immune cells often show enhanced activity in space, possibly due to the improved circulation and reduced stress environment. This enhanced NK cell function contributes to your body's ability to maintain cellular health and prevent the development of abnormal growths. The process of immune tolerance, your immune system's ability to recognize what belongs in your body and avoid attacking healthy tissues, also benefits from space adaptation. The reduced stress and improved cellular function that characterizes space physiology can enhance immune tolerance, reducing the risk of autoimmune reactions while maintaining effective defense against genuine threats. Your adaptive immune system, which includes the complex mechanisms for immune memory and learned responses to specific threats, undergoes its own space adaptation. The T cells and B cells that form the basis of adaptive immunity benefit from the enhanced circulation and improved cellular communication that characterizes space physiology. This often results in more effective immune memory formation and potentially longer-lasting protection against threats your immune system has previously encountered. The innate immune system, which provides immediate, nonspecific responses to threats, also adapts to space conditions. The neutrophils, macrophages, and other cells that provide first-line immune defense often show enhanced function in the improved circulation environment of space. These cells can move more efficiently to sites where they're needed and often show improved ability to engulf and destroy potential threats. Perhaps most remarkably, the overall coordination and communication within your immune system often improves in space. The complex network of chemical signals, cellular interactions, and systemic responses that characterize immune function benefits from the enhanced circulation, reduced stress, and improved cellular environment that defines space adaptation. It's like upgrading the communication system of a vast organization, allowing for more efficient coordination and more effective responses. The circadian rhythms that influence immune function also adapt to the unique day-night cycle of space travel. Your immune system learns to function optimally within the 90-minute orbital cycle that defines your new relationship with day and night. Many immune functions that were previously tied to Earth's 24-hour cycle adapt to maintain their effectiveness within this new temporal framework. The stress hormones that normally influence immune function also change in the space environment. The reduction in physical stress from gravity's absence, combined with the profound peace and perspective that comes from living in space, often results in hormonal profiles that support enhanced immune function. Cortisol and other stress hormones may decrease, while hormones that support immune function may increase. Your body's ability to repair tissue damage, a crucial immune function, also benefits from space adaptation. The improved circulation enhanced cellular function, and reduced mechanical stress of space living often result in more efficient tissue repair mechanisms. Wounds may heal more effectively, and the cellular damage that accumulates from daily life under gravity stress can be more efficiently repaired. The microbiome, the community of beneficial bacteria that lives in and on your body, also adapts to the space environment. These microorganisms play crucial roles in immune function, and their adaptation to space conditions often supports enhanced immune health. The controlled environment of your spacecraft, combined with the physiological changes of space adaptation, can create conditions that favor beneficial microorganisms while discouraging harmful ones. As you sleep each night in your weightless sleeping compartment, your immune system continues its quiet work of adaptation and optimization. The enhanced circulation, improved cellular function, and reduced stress environment of space allow your immune system to perform its essential functions more efficiently than ever before. Your body's defenses are being refined and enhanced, creating immune capabilities that are perfectly suited to your life among the stars. In your dreams, your immune system continues its invisible work of protection and maintenance. You might dream of feeling stronger, healthier, more vital than ever before. Dreams that reflect the very real improvements in immune function that are occurring throughout your body. Your sleeping mind processes the sensations of enhanced health and vitality that come with a perfectly adapted immune system. When you wake each morning, you're protected by an immune system that has been optimized for space living. Every cell, every antibody, every immune response has been enhanced by months of adaptation to the weightless environment. You're not just surviving in space, you're thriving, protected by biological defenses that have been refined to perfection by your remarkable journey among the stars. As you drift through your 6th month in the cosmic embrace of space, floating peacefully in a realm where earthbound concepts of time begin to lose their familiar meaning, your body is undergoing one of its most profound and fascinating adaptations. Your internal clock, that ancient biological timekeeper that has regulated every aspect of your existence since birth, is learning to dance to an entirely new rhythm. The gentle, alien pulse of orbital time that governs life among the stars. For your entire earthly existence, your body has been synchronized to the 24-hour cycle of Earth's rotation, that dependable rhythm of light and darkness that has shaped life on your home planet for billions of years. Every cell in your body carries the memory of this cycle, encoded in genetic mechanisms so fundamental that they operate below the level of conscious awareness. Your sleep, your hormone production, your body temperature, your metabolism, all have been choreographed to this ancient earthly dance of day and night. But now, as you orbit Earth every 90 minutes, experiencing 16 sunrises and sunsets in what used to be a single day, your body is discovering what it means to exist in a temporal landscape that has no precedent in evolutionary history. It's like learning to live in a world where the fundamental nature of time itself has been transformed, where the very concept of day and night must be redefined to match the reality of your orbital existence. Picture yourself floating in the observation cupola of your spacecraft as you pass from the brilliant illumination of orbital day into the profound darkness of Earth's shadow. The transition is unlike anything you ever experienced on Earth's surface, where sunrise and sunset unfold gradually over minutes or even hours. Here, the change from light to darkness happens with breathtaking suddenness. One moment you're bathed in the unfiltered brilliance of the sun, and within seconds you're surrounded by the deep, star-filled darkness of space. Your pineal gland, that tiny pine cone-shaped structure deep within your brain that produces the sleep hormone melatonin, is working to make sense of this new reality. On Earth, this gland responded to the gradual changes in light that signaled the approach of night, beginning to release melatonin as darkness fell and stopping its production as dawn approached. Now, it's learning to function in a world where these transitions happen every 45 minutes, where the very concept of bedtime must be redefined. The adaptation of your circadian rhythms to space is like watching a master musician learn to play a familiar song in an entirely new time signature. The fundamental melody remains the same. Your body still needs sleep, still requires periods of rest and activity, still follows the basic biological imperatives that define human existence. But the rhythm, the timing, the very structure of how these needs are met has been transformed by your journey into space. Your body, with its remarkable wisdom and adaptability, doesn't try to maintain the impossible task of following Earth's 24-hour cycle while experiencing 16 orbital cycles in the same period. Instead, it begins to develop new patterns, new rhythms that are perfectly suited to your space environment. It's a process of temporal adaptation as profound as any physical change you've experienced, a reworking of the very foundations of biological time. Your sleep patterns are among the first to adapt to this new temporal reality. Rather than following the single long sleep period that characterized your earthbound existence, your body might naturally want to adopt a more polyphasic pattern, shorter periods of sleep distributed throughout your orbital cycle. Many astronauts find that they naturally develop the ability to take brief, restorative naps that align with the darkness periods of their orbit, supplemented by longer sleep periods during designated rest times. This adaptation to polyphasic sleep often results in sleep that's deeper and more restorative than what you experienced on Earth. Without the accumulated fatigue of fighting gravity all day, without the stress and complexity of earthbound living, your sleep in space becomes remarkably pure and efficient. Each sleep period, whether brief or extended, seems to provide exactly the restoration your body needs. Your dreams, too, take on new qualities that reflect your adapted circadian rhythms. Instead of the single long dream cycle that might have characterized earthbound sleep, you may experience multiple, shorter dream sequences that occur during your various sleep periods. These dreams often have a different quality, more vivid, more three-dimensional, more closely connected to your space experiences. You might dream of floating effortlessly through cosmic landscapes, of swimming through star fields, of experiencing movement and perspective that could only exist in the weightless realm. The hormone cycles that regulate your body's daily functions are also adapting to your new temporal environment. Cortisol, that hormone that normally peaks in the morning to help you wake up and gradually decreases throughout the day, learns to follow new patterns that align with your space schedule rather than Earth's solar cycle. Growth hormone, typically released during deep sleep periods, adapts to the new sleep patterns of space living, often resulting in more efficient cellular repair and regeneration. Your body temperature regulation, which on Earth followed predictable daily cycles with slight increases during active periods and decreases during sleep, develops new patterns that reflect the unique thermal environment of space. The precise temperature control systems of your spacecraft, combined with your body's adaptation to weightlessness, often result in more stable body temperature throughout your daily cycle, with less variation than you experienced on Earth. The production of digestive enzymes and the rhythm of your metabolic processes also adapt to your new temporal reality. Your body learns to anticipate meal times and activity periods according to your space schedule rather than the earthbound patterns it followed for your entire previous existence. This metabolic adaptation often results in more efficient digestion and nutrient absorption as your body systems become perfectly synchronized with your space lifestyle. Your cognitive performance throughout your daily cycle also changes in fascinating ways. On Earth, you probably experienced predictable patterns of mental alertness and fatigue that aligned with circadian rhythms. In space, many astronauts develop more stable cognitive performance throughout their daily cycle, with less dramatic peaks and valleys in mental energy. It's as if your brain has learned to operate at a more consistent level of efficiency, adapted to the unique demands of space living. The adaptation of your circadian rhythms affects your mood and emotional state in profound ways. The hormones that regulate mood, serotonin, dopamine, and others, adjust their production cycles to match your new temporal environment. Many astronauts report a more stable, positive mood throughout their time in space, possibly due to the optimization of these neurochemical cycles for the peaceful, low-stress environment of orbital living. Your cardiovascular rhythms, too, adapt to the new temporal patterns of space. On Earth, your heart rate and blood pressure followed predictable daily cycles, typically higher during active periods and lower during rest. In space, these cycles often become more stable and efficient, reflecting both the reduced cardiovascular workload of weightless living and the adaptation to new temporal patterns. The fascinating thing about circadian adaptation in space is how it demonstrates the fundamental flexibility of biological time. Your body doesn't simply struggle to maintain Earth rhythms in an incompatible environment. Instead, it creates entirely new temporal patterns that are perfectly suited to space living. It's as if your biological clock is revealed to be not a rigid timekeeper, but a flexible, adaptive system capable of creating new forms of biological time. Your exposure to light, both from the sun during orbital day periods and from the carefully designed lighting systems of your spacecraft, plays a crucial role in this temporal adaptation. The lighting in your spacecraft is often designed to support healthy circadian function, providing bright, full-spectrum light during work periods and dimmer, warmer light during rest periods. Your body learns to respond to these artificial light cues, using them to maintain healthy temporal patterns despite the unusual orbital light-dark cycle. The psychological aspects of time perception also change dramatically in space. Without the familiar temporal landmarks of Earth, the progression of sunrise through sunset, the changing angle of shadows, the social rhythms of human activity, time takes on a different subjective quality. Many astronauts report that time seems to move more slowly in space, that each day feels fuller and more complete than Earthbound days despite being structured differently. This altered perception of time often contributes to the profound sense of peace and mindfulness that characterizes space living. Without the rushing urgency that often characterizes Earthbound life, without the pressure of keeping up with social and environmental time cues that may not align with your natural rhythms, you're free to exist in a more natural, personally optimal temporal state. Your body's repair and regeneration cycles, which on Earth followed the rhythm of daily light-dark cycles, also adapt to your new environment. Cellular repair processes, immune system functions, and other maintenance activities that typically occurred during Earthbound sleep periods learn to optimize themselves for your space sleep patterns. Often, these processes become more efficient in the improved physiological environment of space. The aging processes that occur at the cellular level may also be affected by this temporal adaptation. Some research suggests that the reduced stress and improved physiological function that characterizes space adaptation might slow certain aspects of cellular aging, though the full implications of temporal adaptation for long-term health are still being studied. Your social rhythms, the way you interact with your crewmates and maintain connections with people on Earth, also adapt to the unique temporal environment of space. You develop new patterns of communication and social interaction that work within the constraints of orbital schedules and the unusual day-night cycle of space living. These adapted social rhythms often become deeper and more meaningful than Earthbound social patterns, partly because of the unique shared experience of living beyond Earth's boundaries. The way you experience hunger and appetite also changes as your body adapts to new temporal patterns. Instead of the 3-meal-a-day pattern that characterized Earthbound eating, you might naturally develop eating patterns that better align with your space schedule and the unique metabolic demands of weightless living. Your body learns to anticipate nutrition needs according to your space activity patterns rather than conventional meal times. Your mental creativity and problem-solving abilities often show interesting changes that align with your adapted circadian rhythms. Many astronauts report that they experience enhanced creativity and clearer thinking that doesn't follow the typical Earthbound patterns of mental performance. It's as if your brain, freed from the constraints of conventional temporal patterns, is able to function at more optimal levels throughout your daily cycle. The meditation and reflection practices that many astronauts develop naturally during their time in space also become integrated with their adapted circadian rhythms. The profound peace and perspective that comes from living in space often leads to natural periods of contemplation and mindfulness that align with your body's new temporal patterns, creating a deeply integrated sense of well-being. As you float through the transition from your 6th month toward your 7th in space, your body's temporal adaptation becomes so complete that the 90-minute orbital cycle begins to feel as natural as the 24-hour Earth day once did. You wake naturally during your designated sleep periods, feel alert and energetic during work periods, and experience the deep, restorative rest that comes from a body perfectly synchronized with its environment. In your sleep, whether during brief orbital naps or longer rest periods, your dreams continue to reflect your adapted relationship with time. You might dream of moving through environments where time flows differently, where the concepts of day and night have been replaced by new forms of temporal beauty. Your sleeping mind processes the remarkable adaptation your body has undergone, integrating the new temporal patterns into your deepest understanding of what it means to be human. When you wake, you're greeted by a body whose every system has been synchronized to the rhythm of space, whose every function has been optimized for life in the temporal landscape of orbit. You've become a being whose biological time is perfectly adapted to cosmic time, whose internal clock keeps perfect time with the dance of your spacecraft around Earth. You exist in a state of temporal harmony that's impossible to achieve on Earth's surface, living proof that human biology is capable of adapting to forms of time that exist nowhere else in the universe. As you float through your 7th month among the stars, suspended in the gentle embrace of weightlessness with Earth turning slowly beneath you, something profound and beautiful is happening within the most complex organ in your body. Your brain, that 3-pound universe of interconnected neurons that defines your consciousness and shapes your experience of reality, is undergoing its own remarkable journey of adaptation to life in the cosmic realm. The transformation of your mind in space is perhaps the most subtle and yet the most profound of all the changes you experience during your year-long journey. Unlike the visible changes in your appearance or the measurable adaptations in your cardiovascular system, the evolution of your consciousness in space unfolds in dimensions that are difficult to quantify, but impossible to ignore. It's as if living among the stars awakens aspects of human awareness that remain dormant in earthbound existence. Your brain, that remarkable organ that has served as the command center for your earthly life, is discovering what it means to function in an environment where many of the basic assumptions about reality no longer apply. The neural pathways that developed over decades of gravity-bound existence are being complemented by new connections, new patterns of thought and perception that are uniquely suited to life in 3-dimensional space. The absence of gravity affects your brain in ways both obvious and subtle. The improved circulation that characterizes your space-adapted physiology means that your brain receives a more consistent, efficient supply of oxygen and nutrients than it ever did on Earth. The enhanced blood flow, freed from the constant work of pumping against gravity, delivers its precious cargo to your neural tissue with unprecedented efficiency. It's like upgrading the fuel system of the most sophisticated computer ever created. This enhanced cerebral circulation often manifests as improvements in cognitive function that many astronauts notice within weeks of arriving in space. Thoughts seem clearer, more focused. Mental processing feels more efficient. The fog of fatigue that often characterizes earthbound thinking, partly caused by the constant energy demands of existing under gravity, begins to lift, revealing mental clarity that feels almost crystalline in its purity. Your spatial awareness, that fundamental understanding of where you are in 3-dimensional space, undergoes perhaps the most dramatic transformation. On Earth, your brain develops sophisticated but limited systems for understanding spatial relationships, up and down, left and right, near and far. These systems worked perfectly for a 2-dimensional world with a clear gravitational reference point, but they were never designed for true 3-dimensional living. In space, your brain begins to develop what can only be described as true 3-dimensional consciousness. You learn to think in terms of coordinates that have no earthly equivalent, to understand your position and movement in space without reference to a gravitational up or down. Your mental map of your environment becomes genuinely three-dimensional, incorporating aspects of spatial awareness that are simply impossible to develop on Earth's surface. This expansion of spatial consciousness often feels like awakening to new dimensions of reality. You begin to understand space not as empty void, but as a rich, three-dimensional medium through which you can move with intention and grace. Your brain develops new neural pathways for processing movement and position that create a form of spatial intelligence unlike anything possible in gravity-bound existence. The way you think about movement and momentum also transforms in fascinating ways. On Earth, your brain learned to anticipate the effects of gravity on every action. How fast you needed to move to overcome inertia, how objects would fall if dropped, how your body would respond to sudden direction changes. In space, you're learning to think in terms of pure physics, understanding movement as the elegant interplay of action and reaction without gravity's complicating influence. This new understanding of movement often extends beyond physical actions to mental processes as well. Many astronauts report that their thinking becomes more fluid, more dynamic, as if their thoughts themselves have learned to move in three dimensions. Ideas seem to connect in new ways. Insights arise from unexpected directions, and mental creativity takes on qualities that mirror the weightless freedom of their physical environment. The profound isolation of space, rather than being a source of stress or loneliness, often becomes a gateway to deeper self-awareness and inner peace. Surrounded by the vast silence of the cosmos, with Earth as your only visible companion in an ocean of stars, you're invited into a kind of meditation that's impossible to achieve in the busy, noisy environment of earthbound life. This cosmic solitude doesn't feel empty or lonely. Instead, it feels full, rich with possibility and meaning. The silence of space isn't the absence of sound so much as the presence of infinite potential, a quietness so profound that it becomes a kind of music in itself. Your brain, freed from the constant sensory bombardment of Earth's environment, often experiences a sense of mental clarity and peace that approaches the transcendent. Your relationship with time, already transformed by the 90-minute orbital cycle that governs your daily routine, also affects your mental processes in profound ways. Without the rushing urgency that often characterizes earthbound thinking, without the pressure of keeping up with social and environmental demands that may not align with your natural rhythms, your mind often settles into patterns of thought that are more reflective, more contemplative, more deeply connected to your inner wisdom. Many astronauts develop what can only be described as cosmic perspective during their time in space, a fundamental shift in how they understand their place in the universe and the meaning of human existence. Seeing Earth from space, watching the planet turn slowly beneath you as you orbit through the star-filled darkness, creates a perspective on human life and civilization that's both humbling and inspiring. This cosmic perspective often manifests as enhanced empathy and compassion. From your orbital vantage point, the conflicts and divisions that seem so important on Earth's surface begin to appear as minor variations in the beautiful, unified whole of human civilization. The thin line of atmosphere that protects all life on Earth becomes visible as the precious, fragile boundary that it truly is, creating a deep appreciation for the interconnectedness of all earthly existence. Your creativity, freed from the gravitational constraints that shaped earthbound thinking, often flourishes in remarkable ways. The three-dimensional environment of space, the unique perspective of seeing Earth from orbit, the profound quiet and isolation. All of these factors combine to create conditions that are extraordinarily conducive to creative insight and innovation. Many astronauts report experiencing bursts of creative inspiration that seem to come from nowhere, sudden insights into problems they've been working on for years, or entirely new ideas that emerge from the unique perspective of space living. It's as if the brain, freed from the constant work of managing existence under gravity has extra capacity available for the highest forms of human thought and creativity. The way you process emotions also changes in the unique environment of space. The profound beauty of Earth from orbit, the vast scale of the cosmos, the sense of being part of something infinitely larger than individual human concerns. These experiences often evoke emotional responses that are difficult to describe in earthbound terms. Many astronauts develop a deeper capacity for wonder, awe, and what can only be called cosmic emotion. The stress response systems in your brain also adapt to the space environment. Without the constant low-level stress of existing under gravity, without the complex social and environmental pressures of earthbound life, your brain often settles into patterns of function that are characterized by greater calm and stability. The fight-or-flight responses that were essential for earthbound survival become less active, while the neural systems associated with rest, reflection, and higher-order thinking become more prominent. Your memory formation processes may also be enhanced in space. The combination of improved cerebral circulation, reduced stress, and the extraordinary uniqueness of space experiences often results in memories that are remarkably vivid and detailed. Many astronauts find that they can recall their space experiences with almost photographic clarity years after returning to Earth, as if the brain's memory systems function more efficiently in the optimal environment of space. The way you process sensory information also undergoes fascinating changes. With your visual system adapted to the unique lighting and perspective of space, your auditory system tuned to the gentle sounds of spacecraft operation, and your vestibular system learning to function without gravitational reference points, your brain develops new patterns of sensory integration that create a fundamentally different way of experiencing reality. Sleep and dreaming in space often take on qualities that reflect these mental adaptations. Your dreams may become more vivid, more three-dimensional, more cosmic in scope. You might find yourself dreaming of flying through star fields, of floating through impossible architectural spaces, of experiencing forms of movement and perspective that could only exist in dreams or in the weightless realm of space. The problem-solving abilities that astronauts develop in space often show remarkable sophistication. The unique challenges of three-dimensional living, the need to think creatively about movement and positioning in weightless environments, the constant requirement to innovate solutions for problems that have no earthbound equivalent. All of these demands often result in enhanced cognitive flexibility and creative problem-solving skills. Your attention and focus also benefit from the space environment. Without the constant distractions and interruptions that characterize earthbound life, without the mental fatigue that comes from fighting gravity all day, your brain often develops the ability to maintain sustained, focused attention for longer periods than were possible on Earth. The meditative aspects of space living often lead to what many astronauts describe as expanded consciousness. The combination of physical weightlessness, cosmic perspective, profound silence, and the extraordinary beauty of space creates conditions that are naturally conducive to transcendent experiences and expanded awareness. Your understanding of yourself as a human being often undergoes profound changes in space. Removed from the familiar contexts and social roles that defined your earthbound identity, floating freely in the cosmic realm, you're invited to explore aspects of your consciousness and personality that may have remained hidden during earthbound existence. The philosophical insights that emerge from space travel often center around themes of interconnectedness, unity, and the fundamental nature of consciousness itself. Many astronauts return from space with transformed worldviews, deeper spiritual awareness, and enhanced understanding of humanity's place in the cosmic order. Your communication skills, both with your crewmates and with mission control on Earth, often become more refined and efficient in space. The need to communicate clearly in a mission-critical environment, combined with the enhanced mental clarity that characterizes space adaptation, often results in more precise, thoughtful, and effective communication patterns. The sense of purpose and meaning that many astronauts develop during their time in space often becomes one of the most lasting and important aspects of their mental adaptation. Participating in humanity's expansion into space, contributing to scientific knowledge that will benefit all earthbound life, experiencing perspectives that no human has ever known. These experiences often create a profound sense of life purpose that continues long after returning to Earth. As you float through your daily routines in your seventh month, your mind continues its quiet work of adaptation and expansion. Each day brings new insights, new perspectives, new ways of understanding reality that are only possible from your unique vantage point in space. Your consciousness is being shaped by experiences that no earthbound human can imagine, creating forms of awareness and understanding that exist only in the realm between worlds. In your sleep, as you float peacefully in your sleeping compartment, your brain continues its work of integration and adaptation. Your dreams carry you through cosmic landscapes that mirror the extraordinary reality of your waking life, processing the profound experiences of space living and weaving them into your expanding understanding of what it means to be human. When you wake each day, you're greeted by a mind that has been expanded and refined by months of cosmic living. Your consciousness has been shaped by perspectives that exist nowhere else in human experience, creating forms of awareness and understanding that are perfectly suited to your existence among the stars. You've become a cosmic being, your mind as adapted to space as your body, capable of forms of thought and awareness that bridge the gap between earthbound humanity and the infinite possibilities of the universe. As your year in space draws to its gentle close, as you begin to prepare for the long journey back to the world you once knew, something bittersweet and beautiful begins to unfold. You're about to embark on perhaps the most remarkable transformation of all, the gradual, patient process of returning your space-adapted body to life under Earth's gravitational embrace. It's a journey that's both an ending and a beginning, a completion of one extraordinary chapter and the opening of another that will be shaped forever by your year among the stars. The human body that prepares for Earth return is no longer the same one that launched into space 12 months ago. Every system, every cell, every aspect of your physiology has been transformed by your cosmic sojourn. You've become something unprecedented in the history of life on Earth, a human being perfectly adapted for existence in space, whose body has learned to thrive in conditions that evolution never anticipated. Yet now, with the same remarkable adaptability that allowed you to flourish in weightlessness, your body must begin the reverse journey, slowly preparing itself to function once again in the gravitational environment that shaped the first chapters of your life. It's a process that unfolds with the same patience and wisdom that characterize your adaptation to space, but now in the opposite direction, like a river learning to flow uphill. The preparation for this transition begins weeks before your actual departure from space. Your body, with its extraordinary biological intelligence, seems to sense the approaching change even before conscious preparations begin. Subtle shifts in hormone production, small adjustments in cardiovascular function, gentle modifications in muscle and bone metabolism, all begin to hint at the remarkable transformation that lies ahead. Your exercise routine in the final weeks of your space mission takes on new importance and meaning. The treadmill, the resistive exercise device, the cycle ergometer that have been your companions throughout your space journey now become preparation tools for your return to gravity. Each workout session is like a gentle reminder to your muscles and bones of what they'll soon need to remember: how to support weight, how to move against resistance, how to function in a world where up and down have absolute meaning. But even as you prepare your body for the physical demands of Earth return, there's a part of you that will forever remain adapted to space. The enhanced spatial awareness, the three-dimensional thinking, the cosmic perspective that have become integral parts of your consciousness. These gifts of space living will travel with you back to Earth, enriching your earthbound existence with insights that can only come from having lived among the stars. The process of re-entry itself is like being gently pressed back into a familiar but half-forgotten embrace. As your spacecraft begins its descent through Earth's atmosphere, as the first whispers of atmospheric resistance begin to slow your orbital velocity. Your body starts to remember what it feels like to have direction, to have weight, to exist in a world where things fall down rather than float free. The return of weight is gradual at first, barely perceptible as atmospheric friction creates the faintest suggestion of deceleration. But as your spacecraft descends deeper into Earth's atmospheric embrace, the sensation grows stronger, more insistent. Your body, which has spent a year learning to exist without weight, begins to rediscover what it means to press against something solid, to feel the pull of gravity drawing you downward. The moment your feet first touch solid ground after a year in space is unlike any sensation you've ever experienced. Earth feels solid, almost shockingly substantial after months of weightless floating. The ground beneath your feet has a quality of absolute reality that you had forgotten existed. Each step requires conscious effort as your legs remember how to support your full weight, how to push against the planet's surface to propel you forward. Your cardiovascular system, which had become so elegantly efficient at circulating blood and weightlessness, now faces the familiar but temporarily challenging task of pumping blood upward against gravity's pull. Your heart, which had learned to beat with the gentle efficiency of space circulation, must readjust to the higher pressures and different flow patterns required for earthbound circulation. This cardiovascular readaptation happens gradually over days and weeks. Initially, you might feel lightheaded when standing quickly, as your blood pressure regulation systems remember how to compensate for gravity's effects on circulation. But your heart, that remarkable muscle that adapted so beautifully to space, proves equally capable of readapting to Earth, regaining its terrestrial efficiency with the same patient wisdom it showed in space. Your muscles, which have become so perfectly calibrated for gentle movements and weightlessness, now must remember how to generate the force needed to move against gravity. Walking feels like moving through thick fluid at first, each step requiring conscious coordination as your brain rebuilds the neural pathways for gravity-bound movement. But muscle memory, that deep biological programming, begins to reassert itself, and movement becomes more natural with each passing day. The bones that had so wisely shed unnecessary density during your space sojourn begin the slow process of rebuilding themselves for terrestrial life. The osteoblasts and osteoclasts that had found new equilibriums in space start to shift their balance once again, this time in favor of building rather than trimming. It's a process that unfolds over months as your skeleton gradually remembers its terrestrial architecture. Your inner ear, which had learned to function without gravitational reference points, now must readjust to Earth's constant downward pull. The otoliths, those tiny calcium carbonate crystals that had floated freely in weightlessness, settle once again into their gravity-organized patterns. Your sense of balance, which had become truly three-dimensional in space, gradually remembers how to function in a world with a clear up and down. But perhaps the most fascinating aspect of Earth return is how your space adaptations don't simply disappear. Instead, they integrate with your terrestrial biology to create capabilities you never had before your space journey. Your enhanced spatial awareness remains, allowing you to navigate three-dimensional spaces with unprecedented skill. Your cosmic perspective endures, coloring every earthbound experience with a profound understanding that comes from having seen Earth from space. The fluid distribution that had created your characteristic space face gradually reverses as gravity once again pulls bodily fluids toward your lower extremities. But the improved circulation patterns you developed in space often persist to some degree, contributing to enhanced overall health and vitality that many astronauts maintain long after their return to Earth. Your immune system, which had become so optimized in the clean, controlled environment of space, maintains many of its enhanced capabilities even as it readjusts to Earth's microbial environment. The improved lymphatic circulation, the enhanced cellular communication, the optimized immune responses you developed in space often contribute to better health and disease resistance than you had before your space journey. Sleep on Earth requires its own readaptation as your body learns to rest against solid surfaces once again. The sensation of lying in a bed, of feeling weight pressing you into a mattress, of sleeping in a gravity-oriented position. All of these require gradual relearning. But the deep, restorative sleep patterns you developed in space often enhance your earthbound rest, creating sleep that's more efficient and refreshing than before your cosmic journey. Your relationship with physical exercise is often transformed by your space experience. Having learned to maintain fitness in weightlessness, having developed new understandings of how your body moves and responds to resistance, you often approach earthbound exercise with enhanced awareness and effectiveness. The discipline and body awareness developed in space translate into improved fitness and physical capability on Earth. The cognitive enhancements you developed in space, the improved focus, the enhanced creativity, the expanded awareness, don't disappear upon Earth return. Instead, they integrate with your terrestrial consciousness to create mental capabilities that are richer and more sophisticated than before your space journey. You bring cosmic perspective to earthbound problems, three-dimensional thinking to two-dimensional challenges. Your emotional and spiritual life is often permanently enriched by your space experience. The profound peace of cosmic solitude, the awe-inspiring perspective of seeing Earth from space, the deep sense of connection to the universe that developed during your year among the stars. These experiences become permanent parts of your consciousness, enriching every aspect of your earthbound existence. The readaptation to Earth's day-night cycle requires patience as your circadian rhythms learn to function once again with 24-hour periods rather than 90-minute orbital cycles. Your sleep-wake patterns gradually realign with terrestrial time, but often maintain some of the flexibility and efficiency you developed in space. Physical sensations that you had forgotten during your year in space gradually return to consciousness. The feeling of wind against your skin, the scent of fresh air, the complex symphony of earthbound sounds, all seem remarkably vivid and rich after the controlled environment of space. Colors appear more saturated, textures more varied, sensory experiences more complex and nuanced than you remembered. Your relationship with gravity itself is forever changed. What once felt normal and unremarkable now carries the weight of conscious awareness. You understand gravity not as an invisible given, but as a fundamental force that shapes every aspect of terrestrial existence. Walking, sitting, lying down, all carry new meaning and appreciation. The integration of your space-adapted biology with terrestrial life creates capabilities and perspectives that are unique in human experience. You've become a bridge between two worlds, carrying within your body and consciousness the wisdom of both earthbound and cosmic existence. Your cells remember weightlessness. Your mind carries cosmic perspective. Your heart beats with rhythms learned among the stars. As weeks and months pass after your return, the process of readaptation continues, but it's not a simple return to your pre-space state. Instead, it's an integration, a synthesis that creates something new, a human being enriched and enhanced by having lived in both gravitational and weightless environments. You've become living proof of human adaptability, evidence of life's remarkable capacity to thrive in environments far beyond its evolutionary origins. Your earthbound sleep now carries the memory of weightless rest. In your dreams, you still sometimes float through cosmic landscapes, your sleeping mind revisiting the three-dimensional freedom of space. These dreams don't fade with time. Instead, they become a permanent part of your inner landscape, connecting you always to your year among the stars. The perspective you gain from seeing Earth as a small, blue marble in the cosmic dark influences every earthbound experience. Environmental concerns carry deeper meaning. Human conflicts seem smaller and more manageable. The preciousness of life becomes more apparent. You've gained cosmic perspective that enriches every moment of terrestrial existence. Your body, now successfully readapted to Earth's gravity, carries within its cells the memory of weightless perfection. Your bones remember floating. Your muscles recall the effortless grace of space movement. Your cardiovascular system maintains some of the efficiency it developed in weightlessness. You've become a fusion of terrestrial and cosmic biology. And in quiet moments, when you look up at the night sky and see the International Space Station passing overhead like a bright, fast-moving star, you smile with the knowledge that you've been there, that you've lived among those stars. That part of you will always remain in that weightless realm between worlds. Your year in space has ended, but its gifts continue forever. You carry within yourself the wisdom of adaptation, the beauty of cosmic perspective, the profound peace of having touched the infinite. You've completed the longest journey any human can take, the journey from Earth to space and back again. And in doing so, you've become something unprecedented, a citizen of both worlds, forever enriched by having learned what it means to be human among the stars. Close your eyes now and let yourself drift into the peaceful sleep that carries both the memory of weightless floating and the comfort of Earth's gentle, gravitational embrace. In your dreams, you can return whenever you wish to that year of perfect adaptation, that time when your body learned to dance with the cosmos itself. Rest now, knowing that you've experienced the ultimate human adventure, and let the gentle rhythm of your earthbound breath carry you into dreams that span the space between worlds.